Namaskar, welcome to the channel Anka Ananda Aharan, that is extracting happiness from the teaching learning process of mathematics. Now we are doing some of the problems from linear algebra and its application by Kipperstram, chapter 2. Let us discuss this question. Find the value of C that makes it possible to solve AX is equal to B and solve it. So first we will write the augment matrix 1, 1, 2, 2, 2, 3, minus 1, 5, 3, 4, 1, C. This is my augment matrix. Now applying elementary row operation on it, I will convert it into echelon form. So R2 minus 2R1 stored in R2, R3 minus 3R1 stored in R3. How much it is? 1, 1, 2, 2. First row no change, so directly I copied. Now it is 0, it is 1, it is minus 5, it is 1. Then it is 0, it is 4 minus 3, 1, 1 minus 6, minus 5, it is C minus 6. Next step is, it is similar to here. This pivot, below this pivot, this element I have to make 0. So R3 minus, this is my pivot, so R2 stored in R3. What I am getting? 1, 1, 2, 2, 0, 1, minus 5, 1, 0, 0, 0, C minus 7. So here C minus 7. If this is C minus 7 is equal to 0, then the system has solution, otherwise it has no solution. So for C minus 7 is equal to 0 or C is equal to 7, the system is solvable. Next part of the question is solve it. What we have to do? C minus 7 is equal to 0 means it is last variable is 0. So the equations are 1 माने कौन वेरिएबल थे लगे जाने UVW now last equation, this is last is 0, the my new equation is after C is equal to 7, substituting it 1 1 2 2 0 1 minus 5 1 0 0 0 0. That means here this is pivot, this is pivot, so third variable, that is UVWW, is free variable. So here what are the equations? Equations are V minus 5W is equal to 1, U plus V plus 2W is equal to 2. These are two equations. In this equation, UVW. Here, this is pivot, and this is free. So here I will substitute 1. That will give me V is equal to 6. Now this is 6, this is 1, so 8. This side it is minus 6. So So it has several solutions. The set of vectors which are linear combination of 6 minus 6 6 1 are all solution of this system of equation. So the system has infinitely many solutions, has infinitely many solutions. In particular, minus 6 6 1 is a solution, and any scalar multiple of it is again a solution. So for every value of this w, that means how can I write? The general solution is minus 6w, 6w, w. This is a solution for every value of w. In particular, minus 661 is a solution of it. For every c, find r the special solution, and the special solution x is equal to 0. So here again we will use this space, but because the question is changing, just we'll change the color to avoid confusion. So how much it is? It is special solution. So 1 1 2 2 2 2 4 4 1 c 2 2. For every c, we have to find out the solution. Now let us convert it into its echelon form. So what operation I will do? R2 minus 2R1 stored in R2, R3 minus R1 stored in R3. How much it is giving? 1 1 2 2 0 0 0 0 0 c minus 1 0 0. Now this is not in echelon form. I will change the row position. R2 interchange with R3. What we are getting? We are getting 1 1 2 2 0 c minus 1 0 0 0 0 0 0. So this is the matrix. Now in this matrix there are two possible values of c. For all possible values we are expected to discuss. For c is equal to 1, the matrix reduces to 1 1 2 2 0 0 0 0 0 0 0 0. This. So that implies this system of equation, how many variables? 4. So it is x1 variable now. Let me write down 4 variables, x1, x2, x3, but according to the variables we should write. This is equal to 0 0 0. So here only first variable is the pivot variable. 3 variables are free variables. So what are those free variables? So it is x1, x2, x3, x4. These are free variables. So 1 0 0 0 1 0 0 0 1. And the equation is here, from here, x1 plus x2 plus 2x3 plus 2x4 is equal to 0. So here when I substitute these values, I get, this is minus 1, this is minus 2, this is minus 2. So the special solutions are -1, 1, 0, 0, -2, 0, 1, 0, -2, 0, 0, 1. Directly we can write like this, or we can associate the corresponding free variable to it. That means any vector given to us, what it contains in the second component. So here this variable is x2, this vector is x3, this is x4. How I am deciding what it will be multiplied? In which free variable I have assigned value 1, that free variable I will multiply here. So this is my set of solutions. So the special solutions are, so if we are not multiplying this x2, x3, x4, then also it is okay. If you are multiplying, it is better because it is giving more information. Anything else is there? Okay, so now it is for c equal to 1. If it is c equal to c minus 1 is not equal to 1. So for c minus 1, c is not equal to 1. It is 1, 1, 2, 2, 0, c minus 1, 0, 0, 0, 0, 0, 0. Here, this is my variable. So here free variables are, this is one pivot, this is one pivot. Last two variables are free. And what are the equations? C minus 1 into x2 is equal to 0. So that implies x2 is equal to 0. So here other variables, how we'll write? x1, x2, x3, x4. These are my free variables. Here I will assign 1, 0, 0, 1. Already I got its value is 0. Now from this equation I will find out the same equation whatever we are doing, same equation we will consider. It is x3. x3 means it is -2, and this is x4. x4 again -2. So here these are the two special solutions. Here the null space basis is having two number of vectors. So what are the special solutions? So special solutions are, I can write it as -2, 0, 1, 0. It is -2, 0, 0, 1. If directly we are writing like this, then also it is okay. It is not any problem. But I will prefer to write here x3, here x4, because it gives more information. Similarly, the second question was containing, here it is the second equation, color change. So what it is telling me, a is equal to, so it is 1 minus c, 2, 0, 2 minus c. Already it is in echelon form for c is equal to 2, or for c not equal to 2. In both cases it is in echelon form. So I need not do much. So for c is equal to 1, it is having 0, 0, 2, 1. This is the matrix. So what are the equations then? So here only pivot is, it is not in echelon form. So here the pivot is 2. So that's why I have to make it 0. So half R, R2 minus half R1 stored in R2. It is 0, 2, 0, 0. So this is the pivot variable. That is second variable is the pivot. First variable is free. So it is x1, x2. And what are the equations in this case? x2. 2x2 is equal to 0. It is the only equation. So 2x2 is equal to 0 means here x1 is free, its value is 1, x2 is 0. So only in that case the solution is special solution is only one solution or set of all linear combinations of 1 0 into x1. Okay, for every value of x1 we will get one solution. Now another case is c is equal to 2. When c is equal to 2, it is -1, 2, 0, 0. It is in echelon form. So here this variable is pivot variable. So second variable is free. Equation is minus x1 plus 2x2 is equal to 0. Now here x1, x2. This is my free variable. Here I will assign value 1. So here substituted 1, it is 2. So in this case, the special solution is a linear combination of all vectors in this case. Okay, second case. Here what is the value? C is equal to 2. Now special solution is linear combination of x2 with 2, 1. This vector. For every value of x2, we will get one solution which is a special solution of the given matrix. Next, for c is not equal to 1, c is not equal to 2. In that case, what will happen? 1 minus c, 2, कितने 2, 0, 2 minus c. 2, 0, 2 minus c. So in this case, it is in echelon form and there are two pivots. That means both variables are pivot variables. Okay, so what we will get? Equations are 1 minus c into x1 plus 2 into x2. Okay, bracket दे देंगे 2x2. Actually, these brackets are not necessary. Is equal to 0. Second equation is 2 minus c into x2 is equal to 0. That implies x2 is equal to 0. That implies x1 is equal to 0. So finally, in this case, it has unique solution, that is x1, x2 is equal to 0, 0. This is the only special solution. Directly we could have also done it because it is a full rank. That means the null space is empty. That means only origin vector belongs to null space. That's why x1, x2 is equal to 0, 0. We could have done like this also without going for much. Next question is how to solve it. Now this question, this color will take. Okay. What conditions on B1, B2, B3, B4 make the system solvable? Solve for x. I will do one and then there one column we will reduce to get the other one. Just if I am reducing, observe here, this matrix first and second columns are same as these two. So only third column is extra here. So suppose I am doing this for the whole matrix, and if I am deleting the third column and third variable, then the problem is same as my first problem. So only second problem I will do. The first problem can be done from it. So what is the augment matrix? 1, 2, 3, 2, 4, 6, 2, 5, 7, 3, 9, 12, augmented with B1, B2, B3, B4. So there are three operations I will do. R2 minus 2R1 stored in R2, R3 minus 2R1 stored in R3, R4 minus 3R1 stored in R4. So the new matrix is 1, 2, 3, B1. It remains same. Rest all will change. It is 0, 0, 0. Oh, B2 minus 2B1. Then it is 0, 1, 1, B3 minus 2B1. It is 0, 3, 6 gale 3, 9 gale 3. This is how much it is? B4 minus 3B1. So it is having a 0 row in between. So I have to go for row interchange. So R2, what operation I will do? R2 interchange with R R3 I will do. R3. So what I am getting? The pivot to make the zero pivot to non-zero pivot. So 1, 3, B1. So it is 0, 1, 1, B3 minus 2B1. It is 0, 0, 0, B2 minus 2B1. It is 0, 3, 3, B4 minus 3B1. Now this is my pivot, so I have to make it 0. So how to make it? R4 minus 3 R2 stored in R4. It is 1, 2, 3, B1, 0, 1, 1, B3 minus 2B1. It is 0, 0, 0, B2 minus 2B1. It is 0, 0, 0, B4 minus 3B1 minus 3 times of it is 3B3 plus 6B1. Now it is in echelon form. Left hand side matrix is in echelon form. So that means for first two no condition, but for the last two rows we have conditions. B2 minus 2B1 is equal to 0. That is B2 is equal to 2B1. This is one condition. Second condition, 3B1 plus 6B. So B4 plus 3B1 minus 3B3 is equal to 0. So these two relations will give us the conditions, whenever these two conditions are satisfied, the system has solution. So after substituting these two values, what we are getting? 1, 2, 3, B1, 0, 1, 1, it is B3 minus 2B1, it is 0, 0, 0, 0, 0, 0, 0. Okay. So how much we are getting? Solution. Variable is x1, x2, x3. I will write. I forgot whether UVW or x1, x2. Let me see then. x1, x2. So here two pivots are there. x1 and x2 variables are pivot. x3 is free. Relations are x2 plus x3 is equal to b3 minus 2b1 and x1 plus x2 2x2 plus 3x3 is equal to b1. These are the equations with us. x1, x2, x3. This is my free variable. Here I will value assign the value 1. That means what about my x2 value? b3 minus 2b1 minus 1. Let us substitute that value in this equation. What we are getting here in this equation, let us substitute. So x1 is equal to b1 minus 3 minus minus of minus 1 plus 2 minus of plus 2b1 minus b3. So how much it is? This is 3b1 minus b3 minus 1. So this is my x1. x1 is 3b1 minus b3 minus 1. Okay. So these are the variables table. To avoid confusion, I am making it in a table format. In the table format so that one should not get confused. So my solution to this system of equation is a linear combination of these vectors. That is, what is it? x1, x2, x3. Here this is equal to any scalar multiple of this vector is again a solution. 3b1 minus b3 minus 1, b3 minus 2b1 minus 1 is 1. Any scalar multiple of it is again a solution. I hope it is understood to all. So now its one column is deleted to get the remaining part of the first question. So it is a simplified version of the question done. So I need not do it. Now, what is the rank of this matrix for all possible rank? Okay, when it is rank 2, when it is rank 1, let me verify. For rank, I have to convert it into echelon form. Minus 3, minus 2, 1, 9, 6 cube. So let us convert it into echelon form. It is R2 plus half R1 stored in R2. It is 642. It is 0, half, 0. It is half added. 1, 1, 2. It is 2. Now similarly here it is second equation. It is likhini, but I will write. It is R3 minus 3 by 2. 3 by 2 of R1 stored in R3. R1 stored in R3. How much it is? It is 0, it is 0, it is 3 by 2 gala 1, the q minus 3, q minus 3. This is the matrix third high edge. So here, to get its value, if q is equal to 3, then it is of rank 2. If q is equal to, if q is not equal to 3, then also it is of rank 2. This part of the question again we will do in the next video. Actually, I have a class now, so I have to hurry now. So this question we have not done. Okay. So next video we will discuss about this part. So we have not discussed about this. We will do calmly in the next video. I hope my voice is audible to all of you. Thanks for your patient listening.